to the countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh. Bismillahirrahmanirrahim. So good evening and hi all teachers, parents and all the wonderful students. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with Didik Malaysia and Kelab Guru Malaysia with the hashtag Bermula Percuma, Selamanya Percuma. So before we proceed, let's begin our session with the recitation of Ummul Kitab Al-Fatihah for the Muslim and a moment of silence for the non-Muslim. Al-Fatihah. Okay, so how's everyone today? My prayer that everyone is in the best of health and ready to proceed with today's class. Before we start, let me introduce myself first. My name is Nun binti Muhammad Nuh. You can call me Madam Nun, and I am lecturer from College Matrikulasi Negeri Sembilan. I am your moderator for today's class. Okay. So the most important person today is our passionate, fantastic presenter, Madam Rosmaya. Okay. She is a very experienced teacher from SMJK Yuhua, Kajang Selangor. So let us give a warm welcome to our presenter. For the record, we are now live on Madam Rosmaya channel. So as a sign of support to Madam Rosmaya for her hard work and in preparing to this lesson, please subscribe her channel and my channel too. So as usual, the lesson will last approximately 1 hour. The certificate link and the credit link will be given at the end of this session. Remember that you can only use the email to claim the certificate. For the credit claim, you need to collect the 1 letter and 5-digit code, which will be announced separately during our class today. So be sure to follow the class up till the end to get the complete code for the credit claim. I would also like to remind students, if you wish to post any comment in the chat box, please use appropriate language and use appropriate profile picture. I'm sure that all of you are good students, so please give your full cooperation in making our class lively one. And stay focused. If you have any question, you can write down in the chat box. We will try to provide you the answer. Before I give to the Madam Rosmaya to present, I will announce the first letter and 2-digit code for today's class. So the first letter and 2-digit code is A32. A32. Okay? Or A32. So without further ado, please welcome Madam Rosmaya.
Okay, thank you, Madam Nun. Okay, so now I open my slide. Okay, let me introduce the pre-U teams that we have in Academy YouTuber. Okay, so the first in Academy YouTuber, okay, so this is physics team, okay, lead by me. And we have also one of our member, Teacher Non, here, okay, down me. And the other 2 teachers, Teacher Su and Teacher Habsahayu. Okay, next is mathematics team lead by Teacher Im. Okay, so we also have biology pre-U team lead by Cikgu Faiza. Chemistry team lead by Cikgu Shahnun. Perakaunan and economy pre-U team lead by Madam Fizi. Okay, Academy YouTuber also has apps where you can download it from Google Play Store. Okay, there are a lot of videos there, okay, including our physics video, PDPC video. So you can get from there. Okay, now we have come to the main objective for today's live tuition class. So we are going to do some revision on topics electromagnetic induction and alternating current. Okay. So we go to question 1. Hopefully you all managed to do all the question. There are altogether 10 questions. Okay, so the link to the PDF questions I've given in the description below and also in the chat box there. Okay, you can download from there or refer from there. Okay, so we go to question 1. So we read the question together. Okay, a circular coil of radius 0.10 meter with 50 turns is placed in a uniform magnetic field of flux density 0.56 Tesla. Initially, the plane of the coil is at right angles to the magnetic field. So calculate the initial magnetic flux linked with the coil. Okay, B, the coil then turns through an angle of 30 degrees. So what is the magnetic flux linkage with the coil? So in this question, no diagram is given. So you must be able to imagine from the statement given here to imagine the diagram. But I will draw here so that you know, so that we can imagine together. Okay. So uniform magnetic fields, you must draw the lines, okay, equal in distance with each other, together with the arrow. So the magnitude of the magnetic flux density B is 0.56 Tesla. Okay, next, a circular coil. So observe from side view, we can see that it's like this, okay, a straight line because we observe from the side view. So the radius is 0.10 meter and the number of turns is 50 turns. Okay, so the coil, okay, is drawn perpendicular because it's set here right angles. So perpendicular or 90 degrees with the magnetic field. Okay, so now to calculate the initial magnetic flux link with the coil. This is another point of view. Okay, if from top view or behind, okay, at the back or top view, so you can also draw like this. Okay, it depends on how you draw. Even you can draw it in 3D diagram. So this is another point of view. Okay, so the formula is given by B dot A. Okay, magnetic flux B dot A. So for the magnitude, because this is perpendicularly, so you can just write NB A. So the cos 90 is equals to 1. Okay, if we take the magnitude, so we no need to write the 1 also can. So the area is a circular coil, so we can use area using the circular using the circle area formula pi r squared. Okay, so you substitute all the values given 50 turns, B is 0.56, pi r is radius is 0.10 meter squared, so you get the answer 0.88 Weber. So you can write there if you got the answer in the chat box there. Okay, now we go to question B. Okay, for question B, the coil then turns through an angle of 30 degrees. Okay, so now the coil is no longer perpendicular 90 degrees to the magnetic field, but it turns to 30 degrees. So we are going to find the magnetic flux linkage with the coil. Okay, so now the coil here turns to 30 degrees. Okay, so that means the measured angle is from the vertical because turns through an angle 30 degrees. So be careful where the angle is. Okay, so magnetic flux. This time the second for the second question, I just call it as magnetic flux final. Okay, so the area we need to resolve the component where it perpendicular to the B. So direction of A is normal A must be drawn, okay, normal to the area, to the sectional, cross sectional area, okay, to the coil, okay. So this way lah, this is direction of area of the coil, so it's normal. So now the angle that we resolve, okay, the component is A cos theta, that the angle is 30 degrees. So if the coil is turned 30 degrees, so this A direction also turn 30 degrees. So the component is A cos 30 degrees horizontally and vertically A sin 30 degrees. So that's why I draw the diagram so that you can see clearly where the component we need to use in the calculation for magnetic flux from the formula B dot A. So that's mean the B and A must be parallel to each other. So we choose A cos 30 degrees because it's parallel to B, 0.56 Tesla. So we choose this value. Okay, this is to imagine how the coil is turned 30 degrees in 3D diagram. Okay, can imagine like this. So this is 3D diagram. So for the 2D diagram, we just draw a straight line to represent the coil here. Okay, so now we substitute A cos 30 degrees. Okay, so area is pi r squared. Now substitute everything, okay, every values into the equation. N is 50 turns, B is 0.56 pi, R is 0.10 squared, and then cos 30 degrees. So the answer is 0.76 Weber. So do you realize that the magnitude of the magnetic flux is reduced from 0.88 to 0.76. So the maximum magnetic flux will be at 90 degrees with the B, with the B. So when you turn it to 30 degrees, so it will become less. Okay, so now we go to question 2. Okay, question 2. We read the question. A small search coil of radius r with n turns is positioned so that its center is at a perpendicular distance x from a long straight wire carrying a current I. So draw a diagram to show how the search coil should be positioned so that the magnetic flux linkage through the coil is the maximum. And then B, derive the expression for the maximum magnetic flux linkage. So this time also diagram not given, but the question is asked to draw the diagram. Like just now, the question 1 doesn't ask you to draw the diagram, but this time the question asks you to draw the diagram. So draw carefully. Okay, so it's a straight wire. So you present it in the diagram as a straight line. Okay, straight wire with current I. Then the search coil, okay, with radius r, okay, because it's stated there radius, so it must be a circle, circular coil. And turns, so the perpendicular distance, so that's mean if this is the area, okay, this is the B direction actually, which is distance x, okay, or the axis, okay, axis of the coil. Okay, so the distance is x, okay, perpendicular distance, so it must be 90 degrees here to the wire. So this coil can be in 360 degrees turning, but the question asks for the maximum. So for the maximum, we must draw the coil vertically to the wire here, so that the B direction is this way. If in 2D diagram is out of the screen, but if 3-dimension diagram, I just draw it like this, and to see how it's perpendicular to the distance, look at the diagram, the angle label there. Okay, so B, so for maximum, A also normal to the area of the coil, is must in the same direction as the B. Remember, for maximum, like we've done in question 1, So for the A parallel to B, Okay, so we'll give you the maximum value of magnetic flux linkage. Okay, so that's why we draw it in this way. Okay, must draw it vertically to the straight wire here. Okay, so done for drawing. Okay, next question B. Okay, derive the expression for the maximum magnetic flux linkage. Okay, so now we're going to derive the expression. So the formula still use magnetic flux equals to B dot A. Okay, so magnetic flux B dot A. So it has n turns, so times n. But no more dot because it's parallel. A normal is parallel to B. Okay, correct. So cos 90 degrees. So you substitute the B value, but the B now comes from the wire. Comes from the straight wire. So we use B from the straight wire. So it's no longer B magnet. Like the question once, the magnetic field or magnetic flux then still comes from the magnet, but this time the B comes from the wire. So you substitute the B into here, mu naught I per 2 pi x. So the distance given x, so you must use x. Don't use other symbol than this. Okay, follow the question. This is where students make mistake every year. So they didn't use the given symbol or value in the value is used as a symbol actually. So must use x because given here x, so 2 pi x. Current I, you see current I, then the area is pi. Okay, look at the R here, it's not small letter because given here with capital letter R. So you must write substitute into the radius here as a capital letter R. Okay, then you write it in the proper way. So combine all. So this is the answer because pi can be cancelled out. So it's become mu naught n I r squared per 2x. Okay, so that's the answer. Okay, hopefully you all understand. So if you got the answer correct, you can also mention there. Okay, in the chat box. Okay, but looks like nobody right there. Check Gunon. But it's okay lah. Hopefully you all can understand. Those who cannot understand, you all can understand. Okay, so now we go to question 3. Okay, question 3. A bar magnet falls through a flat circular coil as shown in the figure. So this is the bar magnet. Okay, falling down. Okay, determine the direction of the induced current in the coil. Okay, when the end pole of the magnet is approaching the coil, so this is the end north of the magnet. Then B is when the S pole of the magnet is leaving the coil. So this is the magnet. So the S pole now leaving the coil. So there are two situations. So we are going to use Lenz's law to explain our answer. Okay. So we do A first. Okay, when the end pole of the magnet is approaching the coil. So remember in my PDPC video, okay, we have discussed about 5 steps, 5 or 4 steps of how to determine the direction of the induced current in the coil. Okay, so first step, okay, and before that, okay, why EMF, why current is induced in the coil? Because there is a changes in the magnetic flux linkage. So this is from Faraday's law, if you can remember. Faraday's law state that EMF will be induced if there is a change in the magnetic flux linkage. Okay, so how it changed? Okay, so first step, you determine the direction of the B magnet. So direction of the B magnet is downward. Refer to the magnet here. So you see direction B. So this is north, so it's downward. So you draw the direction downward for the B magnet. Okay, then second step, you check if from Faraday's law we know that the magnetic flux linkage change, then the EMF will be induced. So how the magnetic flux linkage change? is because of the magnet moving towards the coil here. So the magnet moving or approaching the coil, so that means there is a change in magnetic field, okay, experienced by this coil. So how it's experienced the changes, does it increasing or decreasing? So in this case it's increasing. So as the magnet approach the coil, so the magnet around here is increasing. Okay, that's how the changes is. If the magnet stay what you call stationary, so no changes in magnetic flux density. But here magnetic flux density by the magnet change because of the magnet approaching the coil. Okay, so the B magnet increasing. This is how the changes is for the magnetic flux. And magnetic flux is equals to BA. So the changes can be by A and also by B. In this case, is by B, B magnet. Okay, so now the third step, we are going to use Lenz's law. Okay, because of the B magnets increasing, so according to Lenz's law, to oppose the changes, the B induced must oppose, must be in the direction where to oppose these changes. So to oppose these changes, the both resultant by B magnet and the B induced, okay, in such a way that B resultant should be increasing or decreasing. So to use Lenz's law, to oppose means decreasing lah, right? Decreasing. So if the B magnet increasing when approaching the coil, so both resultant by B induced and B magnet must be decreasing. Okay, this is because of Lenz's law to oppose the changes. Okay, so therefore the direction of B induced must be in which direction, so that to decrease or to repel, because this decreasing, right? So that's mean going to repel the north of the magnet. So therefore the B induced must be in opposite direction. Okay, this is how the B induced should be, the direction of the B induced should be. So must in the using Lenz's law, so it must repel this north. So the B induced must position upward. Okay, so now to determine the direction of current, you use a grip rule. So you grip the coil here, okay, so that your all the four fingers here grip the coil here in the direction of the B induced upward, like this. So therefore the thumb shows direction of the current. So the thumb shows direction of the current, which is in the counterclockwise direction or anti-clockwise direction. So this is the answer. So the direction of the induced current is in the anti-clockwise direction. Okay, so now done for the A. Now we go to B. Okay, B, when the magnet leave the coil, okay, so the direction of the first step, determine the direction of the B magnet. So this is south, this is north. So look at the magnetic field by the magnet. So the south, the direction also downward. Look at here. Okay, so downward, B magnet is downward. Okay, so second step, we use Faraday's law. Okay, EMF will be induced if when there is a changes in magnetic flux linkage. So in this case, the magnetic flux linkage change is because of the B magnet increasing or decreasing. So this time it's decreasing because it's moving away from the coil. So the coil, the area here will experience a decreasing magnetic field. Okay, so that's the second step. Then the third step, by using Lenz's law to oppose the changes, so the B resultant must decreasing. Okay, so this one is decreasing, right? So must increasing to oppose the changes. So the B resultant must increase. So that if it's increased, so the direction of the B induced must such a way that it attract the magnet. So that means they must same direction. B induced and B magnet must be in the same direction. So that the B resultant increasing. Okay, another word, if same direction, if you refer to the vector we've learned in last sem, okay, so if same direction, the vector we use plus, remember not? Let's say 4 plus 2 is 6, right? So if opposite direction, 4 minus 2, 2. So it become less, so that the B resultant increase, so they must be in the same direction. or we use the common concept you've learned in Form 4, Form 5. So to attract the S back, here must be S. The coil must be S direction. Okay, south and south. So to north, to attract, right? To attract. Okay, so you use a grip rule. Okay, follow the B induced direction is downward. So the four fingers here follow direction of the B induced. So therefore the direction of the current in the coil is in the clockwise direction. Okay, so that's the answer. And this is the explanation using Lenz's law. Okay, so done. Remember these 4 steps, then it will be safe no matter what situation given to you all. Okay, so we go to the next question. Question 4. Okay, so we read the question together. Two coils X and Y are arranged coaxially like this. Coil X is connected in series with a battery and a switch S. Okay, mark the direction of the induced current in coil Y. And at the instant the switch is closed, and then at the instant the switch S is open. So why here written at the instant? Okay, written at the instant here because at that moment we switch on or switch off, there is a sudden changes in current. Okay, either the current increasing or decreasing. Okay, if closed is increasing, so if open is decreasing. Okay. So there is a changes in magnetic flux. That means that from Faraday's law, there is a changes in magnetic flux linkage. So therefore, we have current will be induced in this wire Y. Okay, neighboring wire for X. Okay, so now first step, remember the 4 step just now. First step, direction of B. So determine direction of B. So we need to know the direction of current. So when this one is switched or switch on, close means switch on. So direction of current is from terminal negative positive of the battery. Okay, then it flow up and around the coil X here, up here. So to determine direction of the X, magnetic field by the X. So we use a grip rule, grip the wire here. Your thumb shows direction of the current. Remember, your thumb shows direction of current. So direction of the B will be to the right, to the left. Okay, follow here direction. So this is the BX. We name the B as the BX because this is B from the wire X. Okay, now when from second step from Faraday's law, okay, when the switch on, when we switch on, so what happened? The magnetic field here increasing. Okay, magnetic field experienced by wire Y will increasing. So there is a changes in magnetic flux. So the EMF will be induced in wire Y. Okay, so now the third step, how the B induced supposed to be. So it in such a way that to oppose the changes, okay, the B resultant must, this is BX increasing, right? So the B resultant must decreasing. Okay, to oppose the changes. So the B induced must is set in such a way direction that both of them when combined will make the B resultant decreasing. So that is from Lenz's law. Okay, so the fourth step from the to make the B resultant decreasing, so the B induced is in such a way how it must be in the opposite direction. Okay, another word, to repel wire X. Okay, so if you use the north and south method, but if you use this method, so it's opposite direction of B. Okay, because the B resultant, the combination of the B should decrease. Okay, so now next, the last step, you use grip rule. The 4 fingers follow the direction of the B induced. You grip the wire Y. This time wire Y because we are going to determine BY. BY already determined, okay, which is B induced. So you grip the wire. Next, lastly, is the direction of current. The question is one direction of induced current. So follow direction of the thumb. So it's downward. By this side is downward. So the question said mark the direction. Okay, so you mark there. Okay, follow the question. Okay, mark the direction of the induced current. So you mark in the coil Y. So that's the first answer. And for the second one, at the instant the switch is open. So this time when the switch open, what happened? Okay, the current, the B decreasing. Okay, opposite of just now. Okay, the B direction still the same because it's the same direction of current when it is closed. Then suddenly we switch off. The BX still the same, but suddenly we switch off. So the B now is decreasing. Okay, the B now is decreasing. This is happen when the switch is open. Okay, so next step, we use Lenz's law. So if the BX decreasing, so that's mean to oppose these changes, okay, the B resultant must increasing, the combination. Okay, so to oppose these changes, so the B resultant must increasing using Lenz's law. So the direction of the B induced must be how? For increasing must same direction. For the B induced must in the same direction, so that we get back the B. Just now decreasing, right? So we want to get it back to increase. So the B induced must be in the same direction. So next step, to determine the direction of the current, so we use a grip rule. Actually the fifth step lah, the fifth step. So we grip the wire according to the direction of the B induced. The four fingers shows direction of the B induced. So direction of current is marked there. Is marked there. Okay, can see. Okay, so now we've done for question 4. So okay, we go to question 5. Okay, Teacher Non, I cannot hear your sound, your voice. Okay, maybe we can stop. We can stop now. Okay. Okay, we can stop now for the break time.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Cannot hear your voice, Cikgu Non, but can slightly hear the sound from your laptop sound. Okay, it's okay. So I will announce the third digit code, right? Okay. Now can hear your voice already.
Okay. So
Okay,
I want to announce the third digit code. Thank you, Rosmaya. So I want to announce the third digit code, which is our third code for today's class is number 2. Okay. So Madam Rosmaya, you can continue with your presentation. Sorry for the technical problem.
It's okay. Maybe it come out late. Your voice. Okay, thank you, Cikgu Non. Okay, so come back to question 5. Okay, we read the question together. A simple AC generator has a coil of 250 turns, each with an area of 20.0 centimeters squared. Okay, the coil is rotated at a frequency of 5 revolutions per second in a uniform magnetic field of 0.85 Tesla about an axis perpendicular to the magnetic field. So calculate the peak EMF generated, then the RMS value of the EMF generated, and C, the instantaneous value of the EMF generated when the plane of the coil makes an angle of 30 degrees with the magnetic field. Okay, so we do question A first. So the formula this time, the formula we use is the NBA omega for the generator. Can remember or not? The generator where EMF is induced in the coil here. If you see the small picture animation down here. Okay, when there is a changes in magnetic flux, so the EMF is induced in the coil here. Okay, so the formula for the peak EMF is NBA omega. Okay, omega here is the angular frequency. Okay, it's supposed to be got cos there for the magnitude. Okay, cos 90 degrees, but we don't need to write there because it's equals to 1. For the peak EMF is cos 90 degrees. So you substitute the omega 2 pi f because given here frequency 5 revolution per second. So we substitute frequency into here. Check the unit. Okay, it's per second, so it's correct. It's 5 revolutions in 1 second. So this is frequency. So substitute everything. 250 into the equation 0.85, correct? Okay, then 20 centimeter squared. Okay, be careful with the unit. Convert to meter squared. So times 10 to the power of negative 4, 2 pi, and lastly 5 for the frequency. And you get the answer 13.4 volts. So this is the peak EMF. Okay, next the RMS value of the EMF generated. So we can use this peak EMF to determine the RMS value of the EMF generated. So the formula is MF RMS equals to peak EMF per Cert2. Okay, so you substitute this 13.4 into the equation divided by Cert2. So the answer is 9.48 volt. Very simple, right? So it's just a direct question. Then lastly, the instantaneous value of the EMF generated when the plane of the coil makes an angle of 30 degrees with the magnetic field. So now the angle change. So that's mean you need to use the formula with the cos theta. So NBA omega cos theta. So cos theta, let's check the angles. The angles is correct. It's 30 degrees with the magnetic field. So make sure the angle given is in between B and A. Okay, so you substitute the cos 30 degrees, but epsilon naught or EMF naught, use the symbol epsilon here, is calculated already in A, so no need to calculate it again. No need to calculate again. So 13.4 times cos 30 degrees, you get 11.6 volt. Okay, so that's the answer. You see, it's become less than 13.4 because the angle is not 90 degrees. So if 90 degrees, then we get the peak EMF. Other than that angles, okay, it keep on rotating here from 0 to 360 degrees, maximum range of angles. Okay, so now hopefully you all understand. If you got the answer correct, you can just join us. Can write there in the chat box. It's long time we haven't get any from you all. Okay, chats there from you all. Okay, hopefully you all got it correct. Okay, now we go to question 6. Question 6. The diagram below shows a battery of EMF 12 volt connected in series with a 6 ohm resistor and a 5 Henry inductor. Okay, inductor, resistor. Okay, calculate the rate of current at the instant the switch is closed. Okay, so the rate means di by dt. So the formula we use, back EMF equals to negative L di by dt. So di by dt is the rate of current. So when the switch is closed, so that means there will be self-induction. The phenomenon occur here is self-induction. So that's why we use the self-induction formula. Okay, L is the self-inductance. Okay, back EMF is induced in the inductor when at the moment where the switch is closed. Okay, so now V supplied by the battery is 12 volt. self-inductance is 5 Henry, and then the resistance is 6 ohm. Okay, so back EMF is equals to negative V supply if there is no loss of energy. Yeah, so we use pure inductor, so pure resistor, no loss of energy here. So negative back EMF equals to negative V supply. Okay, now we substitute this formula into here, and the V supply is 12 volt. Okay, cancel the negative, so bring the L to the other side, 12 per L, and then substitute 5 Henry into the equation, and we get rid of current is 2.4 ampere second. Okay, very simple, right? So we just need to memorize the formula. That's the main problem lah. So in STPM exam, formulas not given. So you need to memorize all the formulas. Okay, now we go to question B. What is the maximum current flowing in the circuit? So I peak or I maximum or I note. It depends on how you write it. Okay, so the maximum current is when at final current. So I name this as final current. That's maximum current. So at the moment the switch is on, okay, so the current gradually increases. Okay, gradually increases because of the inductor here, because of the back EMF. So we need to wait some time, okay, to wait for the current to become maximum. So gradually increase until maximum. Okay, then no more back EMF is induced in the inductor here. So we name it as final current. So at that time, the V of the inductor will be equals to 0, whereas the V across the resistor will be equals to the V of the battery, okay, which is 12 volt. Okay, so we substitute this 12 volt of the battery supply, okay, per resistance here of the resistance 6, so we get 2 ampere. So this is the hidden information where you need to know the concept of back EMF. Okay, so 2 ampere is the maximum current. Okay, now we go to question C. Determine the energy in the inductor when the current is maximum. So we use this current then use the formula of the energy, which is half Li squared. Okay, the formula of the energy stored in the inductor. So half Li squared, substitute the 5 Henry here inductance and the maximum current 2 ampere squared, and you get 10 joule. So this is the maximum energy. This is the energy in the inductor when the current is maximum. Okay, next question D. Okay, calculate the mean induced EMF when the switch is open if the current falls to 0 in 2 seconds. Okay, so now when the switch is off, okay, when the switch is off, so there is a sudden change in current, okay, drop to 0 in 2 seconds. So that's mean back EMF occur, phenomenon of self-induction is occur again. The back EMF occurred again here in the inductor. So we use the same formula. Okay, so the same formula, E back equals to negative L di by dt. So substitute the 5 Henry. Di by dt is negative 2 divided by time in 2 seconds. Okay, so the current change is from 2 ampere to 0. So that's why it's 0 minus 2, so it's become 2. dt is the changes in current. So from 2 to 0, so final minus initial, so you get 0 minus negative 2 is negative 2. Okay, so that's why you get 2 negative here. This is from formula. This is from the change in current. So you get back EMF 50 volt. Okay, so you must substitute correctly the value. So I didn't put the 0 minus 2.0 here. 0 I didn't put. So I straight away put negative. Okay, so the answer is 50 volt. Okay, hopefully you all understand. If you don't understand, you can write there in the chat box. Okay, after watching the live video session also, you can still write in the chat box. Then if got and if I have free time, I will answer your question. So do not worry. Okay, now we go to question E. Sketch a graph of current against time from the instant the switch is closed until it is open again. So from the beginning, the switch closed. Okay, like I said just now, the current doesn't increase at a sudden. So it gradually increase to 2 ampere. So you must label the 2 ampere here because calculated in B already 2 ampere. So if not, no marks. So remember, all must be labeled using what you have calculated in the previous question. So label the 2 there, label the y-axis and x-axis and the 0 there. Okay, at the moment the switch, the time when you switch on. Okay, this is the time when you switch off. So it dropped to 0. Okay, so this is the graph, sketching graph. Okay, next we go to question 7. Okay, for question 7, okay, we read the question. A resistor and a capacitor are connected in series with an alternating current supply. So the RMS voltage across the resistor and capacitor are 12 volt and 8 volt respectively. So what is the potential difference across the resistor and the potential difference across the capacitor at the instant the current in the circuit reaches its peak value? Okay, current, peak value. So peak current, maximum current. So we have two values need to be found. Need to be found. Okay, potential difference across the resistor, potential difference across the capacitor. Okay, so this is to imagine the circuit. Circuit not given, but it always, as a physics student, must always imagine. When you read the question, it's all in your mind. Okay, this illustration, this diagram might help you to imagine. Okay, alternate current and RMS voltage is 12 volt for resistance, and for the capacitance, for the capacitor, RMS voltage is 8 volt. Okay, so there is a hidden information from here. What happened when the current reach peak value? So when the current is peak, maximum, or we name as I peak, so the voltage across resistor here also is the maximum voltage. This is the hidden information. Okay. So when the current is at its peak, so the voltage across the resistance also at its peak, but the voltage across capacitor is 0. Okay. So why this happen? Because I and V are in phase. Okay, this is alternate current. So I and V are in phase. So that's why when I reach peak, VR also reach peak. Okay, so now when at the same time when I reach peak, the V across C will be 0. Okay, V across C will be 0. So we name as VC 0. So this is the hidden information you need to know. The reason here, because in capacitor, I lead V, okay, by pi per 2 radian, okay, for alternate current. So you know this for fast memorizing, you can use the word civil. Can remember or not, in the previous video, PDPC video I post, civil, from the word civil for capacitor, I lead V by pi per 2 radian. So this is the graph. Okay, so when the this is current, so when I reach peak, so the V is 0. Okay, so the V here is 0. Okay, so this diagram might help you a lot. Okay, so now A and D is totally wrong because it gives you value here. 11 volt, 17 volt potential difference across the capacitor. So it's supposed to be 0. Okay, when I is at its peak value. So the rest B and C, we don't know which one now. Okay, so we need to find the potential difference across the resistor now to get the correct answer. Okay, so we use formula VRMS equals to V peak per cert 2 because you are given the RMS value. Okay, so for the resistor, we use 12. Don't use 8. Don't make careless mistake because we are going to find potential difference across the resistor. So we use 12 volt to substitute into here RMS value. So 12 equals to V peak per cert 2. So the answer is 17 volt. The answer is C. Okay. Very simple, right? If you understand the concept. Okay. So now we go to question 8. Okay, in the given figure, which voltmeter will read 0 voltage at resonant frequency omega radian per second, radian per second. So which voltmeter? V1 across R, V2 across inductor, V3 across capacitor, and V4 across both LC. So you need to know the concept of RCL circuit. Okay, RCL circuit or RLC circuit. And the hidden information here, what information can we get from resonant frequency? So at resonant frequency, it means that the reactance, the inductance, reactance is equals to the capacitance inductance, capacitive reactance. Inductive reactance equals to capacitive reactance. Okay, this happened at resonance frequency. Okay, so the formula, because this is RCL circuit in series. Okay, so in the syllabus, we learn RCL circuit in series. We didn't learn the RCL in parallel. So it's easier for you to memorize the formula for RCL in series. So Vz equals to square root of VR squared plus bracket VL minus VC squared. Or you can use the Z equals to square root of R squared minus bracket XL minus XC squared, because current is current in series is the same. Current across R, across L, and not across, flowing through series is the same. So you can get Z equals to square root of R squared plus bracket XL minus XC squared. So we use this one where when XL equals to XC, so that's mean their reactance is the same. So this part will be 0. Okay, so Z impedance, Z is impedance, so impedance will equals to the resistance. So that's mean the voltage across L and C will be 0. Okay, because the Z is equals to the resistance here. So from the V equals to IZ, so Z also equals to IR. So that's mean the voltage for the RCL circuit here, okay, impedance, Z is symbol impedance. So for the RCL circuit here, we name as VZ is equal to voltage across V1. So that's mean V3, V2 and V3 is equals to 0. So that's mean the 0 voltage is, the answer is D, V4, for both of them, L and C. Okay, so that's what we get if resonant frequency, at resonant frequency for the RCL circuit. Okay or not? Okay, hopefully I explain, my explanation is clear to you all. Okay, so now we go to question 9. Okay, question 9. The diagram shows a capacitor connected to an AC voltage. Calculate the reactance of the capacitor in this circuit and the peak current and the RMS current. Okay, so question A, the reactance of the capacitor. So reactance of the capacitor, you can use 1 per omega C, okay, angular frequency, 1 per angular frequency times C. So you don't need to find 2 pi F frequency, because you can get direct angular frequency from the given voltage here. Okay, alternate current voltage, 25 sine omega 100 pi T. So you compare with the general equation, V equals to V peak sine omega T. So the omega there is 100 pi. Can straight away substitute 100 pi. Okay, angular frequency. Capacitance is given in the circuit there, 400 microfarad, convert to 10 to the farad, so times 10 to the power negative 6. So the answer is 7.96 ohm. Okay. Then the peak current, very simple. Also, you can get directly from the equation here. Compare again. So V peak here is 25. Okay, that's the answer. But be careful. The question doesn't want V peak, maximum voltage. But the questions want current, peak current. So peak current, you need to use formula V peak equals to I peak X. Okay, reactance. Okay, so V peak is 25, so V peak formula is I peak reactance, and reactance calculated in A, substitute into here. Okay, so you get peak current 3.14 ampere. So must be very, very careful. What's the questions one? Okay, the questions doesn't want peak voltage, but the questions want peak current. Okay, so you use V peak equals to I peak reactance. If given RMS, you must use IRMS. Okay, for this formula to be used, VRMS must with IRMS, but for V peak is I peak. So must be very careful. So next, lastly, RMS current. For RMS current, you can just use the relationship between I peak and IRMS. So IRMS equals to I peak per cert 2. So I peak from answer in B, 3.14 divided by cert 2. So you get 2.22 ampere. Okay, 22 ampere. Okay, so that's the answer. Now we go to question 10. Last question. Okay, last question now. Before that, because my battery is weak, become weak already. Let me connect to the power supply. Okay, done. Okay, now we read question 10. Okay, the AC voltage V across a capacitor is represented by the graph below. Okay, so which graph represents the variation of current I with time t? Okay, so for this one, you must know which one. For capacitor, you must know the difference of the what you call that. The phase difference between V and I for capacitor in alternate current. Okay, for capacitor in the alternate current circuit, so that's mean I lead V. So this is the graph, right? I lead V. So when AC across a capacitor, so the current lead the voltage by pi per 2 radian and represent by the graph, okay, like this. Okay, so now, the graph is given V initially as the cosine graph. So you cannot use this graph. So this is where the graph is V as a sine graph. So you must be very careful. So this graph is V is a sine graph, but the given graph of V here is a cosine graph. So it's very simple. You just memorize once like this. Okay, I lead V. So this is the graph like we discussed in question previous question before. So you just change to y-axis and x-axis here. So you can see now when the V is a cosine graph, okay, like this cosine graph is similar, right? Cosine graph. So therefore the current is a negative, right? Is a negative sine graph like this. Okay, so the voltage is a cosine function. Must be very careful. The current will be a negative sine function. So the answer is B. Okay, not? Very simple. So if you can remember in the previous video I've shown you to memorize the phase relationship between the I and V for capacitor and inductor. So you can use the civil word. Okay, for capacitor C, I leads V, and for inductor V leads I. Okay, so this is the graph to memorize, but it's very simple. If the V is not given as initially as the V sign, so you just change it to V cos. Right? So the graph of the I will follow like this. Okay, very simple. Okay, so now we go back to question. Okay, so done. We finish. We finished to the end. Okay, thank you for watching. Don't forget to like, subscribe, comment my video and Madam Non video. So I give back to Madam Non the class tuition live class session.
Can you hear me?
Can.
All right. So
Very good.
Alhamdulillah, we have reached our today's lesson. Congratulations everyone, because of you can follow until the end of the class. So before end our session today, I will announce the two last digit code. The digit code is number 4 and 6. Okay, number 4 and 6. So all of you, please stop posting your comment for a while, and don't forget to click the subscribe button and activate the icon bell so that you will not miss any class. Okay, and please share with your friends on your social media. Spread and share the goodness. Once complete, type done on the chat box, and I will post the certificate, paste the certificate link for you in the comment, and also this is the link for the certificate and the link for the credit claim. Okay, so wait. Okay, the line is not very clear, so please wait.
But I can hear
Another while.
clearly your voice.
So you can clear my voice clear.
Only my picture, means my video.
Okay,
I can
that
hear
is
you
okay.
clearly.
So, thank you, Madam Osman. So please take note that the link will end half an hour after this live. Make sure that you use the email EDDate and MOE to log in. So incorrect email will not be entertained. And if you haven't got one, you can apply the email, the EDDate email. If you wish to get more information on the online class, go to www.academyyoutuber.com. And those who haven't joined EDD Junior Telegram, please do so. So once again, I would like to thank all students for joining today's class. You are very awesome. Feel free to share this free tuition class to your friends and teachers all over Malaysia. This is the collective effort from all teachers throughout Malaysia for all students throughout the country. Thank you for being a YouTuber Academy supporter too. So I think that's all for now. See you in another lesson. Please remember the hashtag bermula percuma, selamanya percuma. So stay safe till we meet again next week, same day and same time. Assalamualaikum and bye everyone.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.